Hi folks, this next PowerPoint has to do with anthropogenic sources of climate change. Now, genic means created by and anthro means man. So all the climate shift that we're going to be talking about in this PowerPoint has to do with that has been attributed to people. The number one way that people around the globe impact greenhouse gases in the atmosphere is through the combustion of fossil fuels, namely coal, oil, and natural gas. Now, in our little segment on natural climate shift, we learned that fossil fuels actually, the creation of them takes carbon out of the ocean atmosphere system by burying it. And now I'm telling you that when we burn it, we're taking that carbon from those dead organisms and we're reintroducing it to the atmosphere. And the primary gases that are emitted during this combustion or burning of fossil fuels include carbon dioxide, methane, which is CH4, water vapor, H2O, and ozone, which is O3. Now remember that a greenhouse gas is one that basically traps heat in the lower atmosphere around the Earth and warms it up over time. People talk about carbon dioxide a lot because it is a huge amount of greenhouse gases that are emitted, but methane or CH4 actually can absorb 10 times as much heat as carbon dioxide, and so even though it's in much lower quantity, it is pretty significant. Water vapor is also hugely significant in greenhouse gas concentrations. So if you think about a pool in the summer, pools are, you jump in the afternoon to cool off because the air is really hot, but the water takes a long time to warm up. So the water is still kind of refreshing. But later in the evening, when the sun is set and the temperature in the air is dropping, the water in the pool is still warm. And that's because water has the ability to, once it does warm up, retain a lot of heat. And that is why water vapor in the atmosphere also will retain a lot of heat. Now ozone, or O3, up in the upper atmosphere where you have the ozone layer, is great because it helps to reflect ultraviolet rays from the sun back out into space. But ozone at lower altitudes actually can bother people with respiratory diseases like asthma and other things. So ozone at low elevations, not so good. Up in the ozone layer, good stuff. On this first slide, you also see a picture of the greenhouse effect. And basically what this means is that the sun basically emits about a constant amount of solar radiation over time. And about half of that solar radiation bounces off of clouds and ice and things like that in the atmosphere and go back out into space. About half of it gets absorbed by the Earth, and then depending on the amount of greenhouse gases in the atmosphere, a lot of or a little of that heat that's absorbed and then re-radiated back out into space, some of that can be absorbed at a higher concentration when greenhouse gas concentrations are higher. So when you go to the next slide, you see a map, or not a map, sorry, you see a diagram showing carbon emissions in gigatons over time, starting in 1950 and going to 2007. And you see a bunch of different countries here. Probably the one that stands out, the two that stand out the most are China and the United States, right? Because China currently is the number one emitter of greenhouse gases in the world, and the United States is number two. Now the shape of these curves is very different, and that's because over time, especially in the last 10 years, the Chinese economy has boomed because they make a lot of stuff, and they make a lot of stuff pretty inexpensively. And it turns out that because our economies are so tied to fossil fuels for manufacturing, that the more manufacturing you have, the more carbon dioxide, the more carbon you're generally emitting. So you can see that with the expansion of China's economy, so has their greenhouse gas emissions. The U.S., while we've certainly experienced economic growth since the 1950s, we've done it at a steadier rate. And when you look at both China and India, you probably notice that the shape of their curves over time seem to increase more rapidly because they are what are known as developing economies, developing nations. Same thing with Japan, sort of in the 1960s and into the 1970s, although their growth has slowed to what you see in most sort of well-established industrialized nations like the US, Germany, Canada, the UK, I think places like that. If you look at Russia, Russia's economy has actually shrunk a bit. In the early 1990s, the Soviet Union collapsed, And when that happened, the Russians suddenly had to compete with a global economy and not just with other states in the Soviet Union. And so, by and large, their economy slowed down a bit in the mid to late 1990s. Another very significant source of greenhouse gas emissions globally is deforestation, the destruction of permanent, mature forests. And what you see in this diagram is a series of time slices of the country Borneo, which is in Southeast Asia, from 1950 projected to 2020. And this green area here shows the amount of canopy coverage, or the amount of forested land basically in Borneo, which you see is almost 100% in 1950. And then you see a progressive decline in the amount of area covered with forest between 1950 and by the year 2020 it's predicted that there'll be less than a third of Borneo covered with forests. So this is an enormous problem for industrialized countries, but for these developing nations, deforestation is a significant issue, which we'll talk about more on the next slide. One of the biggest benefits of forests is that they have the ability to basically suck up carbon dioxide, like all plants, and turn it into free oxygen. And so it's a reasonably good short-term solution to pulling carbon dioxide out of the atmosphere. One of the things that's done, unfortunately, kind of frequently in places like the rainforest is what's called slash and burn techniques. And because the soil is so poor in some of these rainforests, what different farmers have done is basically to burn some trees down, which puts all sorts of good nutrients into the soil, but because it rains so frequently in this area, what ends up happening is that within a 7-year period, that all those good yummy nutrients that can create really good farmland get basically leached out of the soil. So in about 7 years, they have to cut down these beautiful rainforests and do the whole thing over again to keep maintaining farmland. And also, a lot of rainforests are cut down because they're full of economically useful trees. So when you burn the trees, you do put a lot of nutrients into the soil, but you also end up releasing that carbon that's stored in the tree back out into the atmosphere. One of the most significant challenges that we'll be facing in the next 100 years is enormously burgeoning populations on Earth. And people need stuff. And I'm not talking about like people needing iPods and cell phones and things like that, but people need food and people need water and people need a place to live. And so those demands put a strain on our ecosystem. So what you see in this picture here is a 21-year span of time in Bolivia. So the before picture shows like a river and maybe a small village. And the after picture shows what happens when you don't have really great access to health care. You have maybe slightly better health care than you did 50 years ago, but you don't necessarily have readily available birth control, and so you have huge growing populations. So you have to put people somewhere. So what do? Well, you have to cut down some trees to make room for some houses, and then you use the trees to build the houses, right? So we've all seen plots of what basically look like house farms, but when you have a new housing tract going in an area, they cut down all the trees, right? So that you can get in equipment to put in houses. And they put in those silly little trees that don't really absorb nearly as much water. What happens with all the extra water then when it rains is that generally places will build storm sewers, and then those storm sewers, in most of the world, those storm sewers will just basically send that water directly out into rivers. And so every time it rains, any sort of pollutants that might be in the yard, on your sidewalk, or whatever, garbage that people throw on the side of the road get flushed into the river. So you have sort of a pollution issue there. So the other thing you probably notice is that river seems to get a whole lot smaller 20 years later, and that's because people need water. So there's increased need for water, but the potential for pollution is much greater. So that's problematic as well. So burgeoning populations is something that we'll have to be dealing with at some point in the future. In the United States, we still do have a birth rate that is is pretty steady but pretty low. A lot of European nations actually have what are considered negative birth rates, where people aren't actually even replacing themselves in sort of like an evolutionary sense, and families are becoming smaller and smaller, while in developing countries you still have very large family sizes. All right, and finally, the third sort of enormous contributor to greenhouse gas emissions is actually agriculture, which accounts for about 20% of all greenhouse gas emissions in the global sense. And so here you have a funny picture of a cow, and that funny picture of a cow is only part of the story about agriculture. So this morning for breakfast, I had a banana. And that banana came from Costa Rica. That banana had to travel 2,000 miles so that I can buy it at Wegmans for 49 cents a pound. So think about the cost in transport for produce. Like there's no real seasons at the grocery store anymore. You can buy blueberries year-round from Chile. And so in order to make that happen, what farmers in Chile have to do is to pick those blueberries before they're actually ripe, and then they're sort of put in this sort of gaseous concoction on their way between Chile and Rochester to ripen them up. They're not as nutrient rich as they would be if they were grown locally. Can I just pick them? But they get here and they're pretty and they're good, and so I buy them. But they travel thousands of miles by air and ground transportation, and then I buy them. Now cattle represent an interesting and somewhat different issue, and that is that by and large in our country now the food system has been industrialized to the point where you don't really have too much of that ideal sort of agrarian society anymore, where you have a red farmhouse and some cows thinking happy profound little cow thoughts while they chew their grass any longer. In most of the country, the way that cattle are raised now is on what are called confined animal feeding operations, where you have maybe 20,000 head of cattle on a relatively small plot of land. And whenever you have that many anything in that close of a proximity, the potential for disease is huge. So cows in the United States generally now are fed a healthy dose of antibiotics so that they don't get sick because they're around other cows. And it turns out that cows will grow faster if you feed them more fat. So a lot of cows are fed a good amount of fat so that they grow, and farmers have been able to take almost a year off the life of a cow by having them grow faster and given growth hormones and things like that also to make them grow faster. And so cows still eat some grass, but a lot of what they eat is actually corn now, because in the United States we grow a tremendous amount of corn for a bunch of reasons. There's a lot of incentives for farmers to grow corn, first of all, government incentives, and then part of the reason that those incentives are in place are because corn is a type of crop that's easily transportable and it's easily storable, and so in case of food shortage, corn is great. We grow so much corn in this country that we make crazy things, and if you've ever looked at your cereal box, you'll see them. Things like lecithin and maldextrose and high fructose corn syrup are all byproducts of corn created in laboratories because we have all this extra corn. And so cows are fed corn. And so cows are sicklier now, and their meat is less nutritious than it used to be, and it's fattier. But you can get a hamburger for like 49 cents, which is cheaper than you can buy broccoli. So take that for what you will. But agriculture, in terms of, again, transporting all these cattle, feeding these cattle corn, having to transport the corn to the cattle, all of those things add up to greenhouse gas emissions because all of them involve at least a little bit of transportation cost, and transportation equals gas, and gas equals carbon dioxide.